I'm Jon Maddy and I run the University of South Wales Hydrogen Centre at Baglan, and my role on RICE is to manage our work package 5, which is largely to do with hydrogen in many of its use aspects, but effectively it's to manage the more efficient offtake of hydrogen from industrial processes, how hydrogen can reduce the carbon in those industrial processes. We're looking at ways in which we might use industrial heat to ease the electrolytic process of making hydrogen, splitting hydrogen from water, separating hydrogen and oxygen to form hydrogen. To form hydrogen and oxygen from water, as I say. So there's that element. We're then also looking at better ways of capturing hydrogen from existing industrial streams. So, for example, within steel making, there are a number of gaseous streams that arise that have hydrogen content in them. There are ways of capturing that hydrogen that are widely deployed around the world. We're looking at perhaps more novel, more efficient, more useful ways in capturing that hydrogen. The other aspect of the work package is to look at the way in which hydrogen can be used to decarbonise heat. If you think of majority of our existing heating, both domestic and industrial in the UK, is done by means of natural gas. The problem being, of course, that it carries with it carbon. Natural gas itself, when combusted, then gives rise to carbon emissions. If you get fugitive emissions of the natural gas, then that has a greenhouse gas potential as well. So effectively what we're looking at is the way in which we might change or make a transition for that industrial, commercial and domestic system, so that we might decarbonise that by means of either putting smaller amounts of hydrogen, so using hydrogen to sort of partially displace some of that natural gas, or fully replacing the natural gas with hydrogen. Mostly looking at the idea that you could capture excess renewables. When I say excess renewables, this is perhaps a way of getting more renewables onto our electricity grid system. But of course, let's take renewable wind. You generate when the wind's blowing, you don't when the wind's not blowing. There's a variability of that. And our electricity systems, our electricity demand is not necessarily in sync with that production. So a proposal that we'll investigate through RICE is the idea that you can capture during periods of excess, capture that electricity, convert it to hydrogen, and then use the gas network as a means of storing that energy. How you then recreate electricity would typically be looking at standard gas-fired power stations in that case, but it might also be looking at fuel cells to do that more efficiently. And then there's this sort of slightly more, well, I was going to use the word extreme, but it's more fully decarbonised case where you actually displace all of the natural gas in parts of the natural gas network. And whilst that might sound relatively far-fetched, if you look back to the time that we used Towns gas, before we discovered North Sea gas and started using North Sea gas, most cities had a gas generation plant, typically using coal in those days. But the point I'm making is that the gas that was produced and then put down our pipelines typically had anywhere from 50 to 65% hydrogen in it. So the concept of using hydrogen on a mass scale for our domestic, commercial and industrial heating systems is not necessarily a new one. And the final element is to do with hydrogen as a transport fuel. And if you look at it, hydrogen with no carbon can be combusted, and that's what I've already sort of talked about in a heating context. But it can also be used in a fuel cell, and is being used in many fuel cells on board vehicles, whether they be passenger cars, whether they be buses, whether they be light or heavy goods vehicles. And indeed, one sort of newer element that's attracting a lot of interest is the use of hydrogen on board trains. So instead of using diesel, which many of those vehicles would, and combusting that diesel with all of the emissions problems that generates, both in terms of carbon or CO2, but also in terms of particulates and other emissions. If you used hydrogen as the fuel, you use the fuel cell as the main sort of energy generator in that respect, or electricity generator in that respect, on board the vehicle, then you can have a complete zero carbon vehicle, at least at point of use. If you look at the future of decarbonisation through hydrogen, in a way you need all of those little pieces of the jigsaw to fit together. Doing them one-off, helps, and at this stage we're at that stage where you need to do those sort of discrete demonstration activities and development activities, and we've been doing that for a while. But if you're really talking about hydrogen as one of the main ways in which we decarbonise, that it becomes a fuel that we regularly use day to day, if it becomes part and parcel of our industrial processes, then we need to bring them all together, bring all of those facets all together. So that's, I suppose, the sort of overriding role of our activity in RICE.